Hello and welcome to Algebra 2 Lesson 16. In this video, we're going to learn about graphing linear equations in two variables. So in our last lesson, we covered the basics of a linear equation in two variables. And if you took an Algebra 1 course, not only was that a review, but this will be a review as well. Learning how to graph a linear equation in two variables is very, very simple, particularly if you've done it before. So I want to kind of just start out by covering some of the things we talked about in the last lesson. We're going to go through them very quickly, and then we're going to ramp up and start doing some graphing. So a linear equation in two variables looks like this. It's ax plus by equals c, where a, b, and c represent real numbers, and a and b are not both 0. So a can be 0, b can be 0, but they're not both 0. So in this example, 5x plus 2y equals 20, you can see a represents 5, b represents 2, and c represents 20. Now another key point here is that the exponent on each variable is a 1. So I have 5x to the first power plus 2y to the first power equals 20. I would not have a linear equation if the exponents here were something like 2 or 3, for example. So with that behind us now, let's talk about a couple of things with the linear equation in two variables. The first thing is that there's an infinite number of solutions. I can choose a value for x. Let's just say 0, for example. I plug it in, I'd have 5 times 0 plus 2y equals 20. Well, this is 0. Now I have a linear equation in one variable. I have 2y equals 20. I know that x is 0 because I plugged a 0 in to start. I just need to find out what is y when x equals 0. So I divide both sides by 2, and I get y equals 10. So one solution of the infinite number would be that x is equal to 0 when y is equal to 10. And if you want to, you can plug in a 0 for x and a 10 for y, and you'll see you get the same value on the left as the right. Let's do that real quick. 5 times 0 plus 2 times 10 equals 20. This is 0 plus 2 times 10 is 20 equals 20. You get 20 equals 20, so this checks out. But the main thing here is to realize that I can keep doing that. I could choose a different value for x, and I would get a different value for y. So let's say, for example, I chose the value of 2 for x. So I plug that in now. So 5 times 2 plus 2y equals 20. 5 times 2 is 10, so this is 10 plus 2y equals 20. Subtract 10 away from each side of the equation. This cancels. I'll have 2y is equal to 20 minus 10 is 10. Divide both sides by 2, and I get y equals 5. So here, x equals 2 when y is equal to 5. So this is a big change for us because we're used to solving linear equations in one variable. And with those type of equations, we generally just have one number that works as a solution. Okay, we don't have an infinite number of solutions that we can just generate. But it's good to see this because it leads me to my next point. If you have an infinite number of solutions, you need a way to kind of visualize the solution set. And what we do with this is we graph. Okay, we graph a line on a coordinate plane to kind of say, hey, here's a visual representation of the solutions for this linear equation in two variables. Now let's talk about how we would go about graphing something. The first thing is that each solution can be written as something known as an ordered pair. So we talked about that in the last lesson. An ordered pair is x comma y. So the order is important. I put my x value first, followed by y. So with x equals 0, y equals 10, the ordered pair would be 0, that's my x value, comma, and then 10, because that's my y value. For this one, it would be 2, comma, 5. And I could generate more if I wanted to. And let's generate one more, actually. Let's see what happens when x equals 4. So x equals 4. What is y? So plug in a 4 there. We'd have 5 times 4 plus 2y equals 20. We know that 5 times 4 is 20, so you'd have 20 plus 2y equals 20. Let's subtract 20 away from each side of the equation. So that'll cancel. We'll have 2y is equal to 20 minus 20 is 0. divide both sides by 2, and we'll get that y is equal to 0. So if x is 4, y is 0, or as an ordered pair, it's 4 for the x value, comma 0 for the y value. All right, so in the last lesson, we talked about how to plot the ordered pairs. So let's go down to the coordinate plane, and we're going to do that. All right, so this is our coordinate plane. And the coordinate plane consists of 2 number lines. So we have a horizontal number line and a vertical number line. So the horizontal number line is known as the x-axis. So this is the x-axis. The vertical number line, the one that goes up and down, is known as the y-axis. So when we talk about our ordered pairs, let me paste those real quick. We have 0, 10, 2, 5, and 4, 0. All we do is we find the kind of intersection or the meeting point of the 2 locations. One location's for x, one location's for y. So in other words, let me kind of go to this middle one. For 2, 5, remember it's x, y. So an x location of 2, if I go on the x-axis, a location of 2 is just right here. For 5, the y location, I go on the y-axis, a location of 5 is right here. So where's the meeting point between the two? Well, I'm going 2 units to the right, 5 units up, it's right here. So this is the point 2, 5. Now when we start talking about 0 as a location, it gets a little bit complex, because you have to kind of think a little bit. The lines intersect at 0, 0. This is the meeting point of the x-axis and the y-axis. So if I look at 0, 10, okay, that's telling me that I don't want to move it all on the x-axis. So I would just sit right here, and I would say, well, the y location is 10, that's here. So I'm only going to go up 10 units to arrive at my point. This is 0, 10. Now for 4, 0, now I'm going to be on the x-axis because 4 is on the x-axis, it's 4 units to the right. The y location is 0, so I'm not going to move up or down at all. I'm just going to stay on the x-axis. This right here is 4, 0. Now once I have 2 points, I have enough for a line. The rule is 2 points make a line, but you always want to use a third one as a check because I can make any 2 points line up. But if I have a third one that's off, so I get something that looks like this, I've got a line going and then there's a point over here, so that's not a line. So you know you made a mistake somewhere. But if you have 3 points and it just kind of flows into a line, you know you got the right answer. So what I'm going to do is I'm going to draw a line through our 3 points here. And what we want to do is we want to put an arrow at each end. And what does that arrow indicate? It indicates that this line continues forever and ever and ever in each direction. Again, there's an infinite number of solutions, an infinite number of x, y pairs that satisfy this equation. Every single point on this line, every single spot represents a solution to that equation that we started with, which was 5x plus 2y equals 20. And a common thing to do would just be to label the line. So 5x plus 2y equals 20. This line, again, represents the solutions to this equation. Now, there's a very important concept that I want to cover with you real quick. The concept would be that of an x-intercept and a y-intercept. So an x-intercept is where your graph crosses the x-axis. So this right here is your x-axis. This graph crosses the x-axis right here at this ordered pair 4, 0. So that's my x-intercept. Let me label that real quick for you. So this point right here is the x-intercept. Now, similarly, the point where the graph crosses the y-axis, this is the y-axis going up and down, is known as the y-intercept. So this, let me just label that right there, is the y-intercept. So a couple of key things here that we want to cover. The x-intercept, again, is where the graph crosses the x-axis. So to find this mathematically, you're not always going to be graphing stuff. You want to plug in a 0 for y and solve for x. Let's think about this for a second. Let's go back to the graph. Why does that make sense? Where would I cross the x-axis at? Well, on the y-axis, I can't go up or down. if I'm going to hit the x-axis. Just think about erasing this axis for a minute. If I'm touching the x-axis, I've got to be at 0 on the y-axis. If I cross here, at this point I'm at 0. If I cross here, at this point I'm at 0. Anywhere you cross the x-axis, y will be 0. Okay, so that's very important to understand. The second thing would be for the y-intercept, again, where the graph crosses the y-axis, you'd plug in a 0 for x and solve for y. Again, looking at this thing, we see that at the y-intercept, the x location is 0. You can even see it right there, x location of 0. At the x-intercept, the y location is 0. So that's how we find these things. If I want the x-intercept, plug in a 0 for y, solve for x. If I want the y-intercept, plug in a 0 for x, solve for y. All right, so now that we've graphed our first equation, let's talk about one particular method to graph equations. Now, we just used it. We didn't know we were using it, but we did. It's something known as the intercept method. So it's easy to work with 0 as kind of one of your values. 0 is easy to work with. You multiply by 0, it disappears. You add 0, you get the same thing, so on and so forth. So the whole thing with the intercept method is I'm going to find the x and y intercepts, and then I'm going to find one point as a check. Now, for this one, I have negative x plus 4y equals negative 4. So when I look at ordered pairs, or if I create a table of values, then I would find the y-intercept by plugging in a 0 for x. I'd find the x-intercept by plugging in a 0 for y. And then I'd pick some number arbitrarily to get a check. Now, when you pick a number arbitrarily, you want to make sure that you end up with integers. The reason for that is you don't want to end up with decimals or fractions and trying to graph this on something where, the scale is in integers, okay? You can do it, but it's very, very tedious. So try to work with integers. Just try your best. So I'm going to start by plugging in a 0 for x here. I would have negative 0. That's just going to go away. Plus 4y equals negative 4. Divide both sides by 4. You get y equals negative 1. So if x is 0, y is negative 1. Again, this is the y-intercept. When we graph it, I'll show you. It's going to cross the y-axis there. For the other one, let's erase this real quick. We're going to plug in a 0 for y now. Find the x-intercept. So we'd have negative x plus 0 times anything is 0. So I can just mark this out. I can have negative x equals negative 4. Multiply both sides by negative 1. I get x equals 4. So then this right here would be our x-intercept. All right, let's erase everything. Now again, 2 points make a line. So if you're 100% confident that you got the right answer here, stop and do it. You can plot 0, negative 1, 4, 0, draw a line through it, and you're done. But again, if you're like me and you're cautious, you want a third point as a check. So you want to pick something that's going to produce an integer result. So how do you do that? Well, you can kind of eyeball this and tell what would work and what wouldn't. If I plugged in a 1 here, just think about this for a second. You get 4 times 1, which is 4. So you'd have negative x plus 4 equals negative 4. Without doing anything else, that's going to work because if I subtract 4 away from each side, I would have negative x is equal to negative 8. I'm going to end up with an integer result. So I'm going to go with y equals 1, and then x, if I multiply each side by negative 1 here, x is going to give me positive 8. So now I can just label this as a check. This is my checkpoint. All right, so let's erase everything. And we have 3 ordered pairs. We have 0, negative 1. We have 4, 0. And we have 8, 1. So let's copy these. All right, so we paste our ordered pairs. And again, I just want to label this as the x-axis and this as the y-axis. And we're going to plot each ordered pair. So 0, negative 1. So 0 is the x value. So I'm not going to move it all left or right. Negative 1 is the y value. So I'm just going to move down. That's right here. Now, remember, if x is 0 and y is negative 1, that is the y-intercept. And notice how when we graph this, it's going to cross right there. It's going to touch the y-axis, And again, that's the definition of the y-intercept. It's where it crosses the y-axis. Now the next one is 4, 0. So my x location is 4, my y location is 0. So I'm not going to move it all vertically. So that's going to be right here. Now notice that this is where the graph is going to cross the x-axis. Again, this is the x-intercept. Then lastly, my point for a check is 8, 1. So I find 8 on the x-axis, that's right here. I find 1 on the y-axis. So think about it as going 8 units to the right, 1 unit up. And everything lines up here. So I know that I've got something going. Okay, and again, I want to put arrows at each end. And the arrows indicate that this line continues forever and ever and ever in each direction. So once we've graphed our line, again, it's common to label it. So we'll say this is the graph for negative x plus 4y is equal to negative 4. Okay, just label it like that. And you're not required to label it, but it's good practice, especially when you begin. And again, I just want to call your attention to this one more time, where y is 0 at the location 4, 0. This is the x-intercept. This is where we cross the x-axis. Okay, where x is 0, which is 0, negative 1, this is the y-intercept. This is where we cross that y-axis right there. Okay, so again, the x-intercept, the y-intercept, two very important concepts for you to get down, something you need to know right away. So kind of the next thing that's going to occur is you're going to run across these equations where your intercept occurs at the origin. So when this occurs, the x and the y-intercept are going to be there, and it's known as a line that just passes through the origin. You will encounter this as ax plus by equals c, where c is 0. So you might see something like 4x plus 2y equals 0. I know this is a line passing through the origin because it's in this format. Or something like negative 3x minus 7y equals 0. You're looking for something times x plus something times y equals 0. Again, that's a line that passes through the origin. So here's an example. We have 3x plus 4y equals 0. So we see it, we eyeball it, we say, I know this passes through the origin. So if I try to use my intercept method, what's going to happen? Well, the x and the y-intercept occur at the same spot. So I got to pick 2 additional points, not 1. So if I put 0 here, I know 0 here works. And you can eyeball it and see if I put a 0 here and a 0 here, 3 times 0 is 0, plus 4 times 0 is 0, 0 plus 0 is 0. So once we've identified that, we get a point for free. We know automatically 0, 0 works. All right, for the next point, again, just think about using things that will produce integers. So a good way in this situation would be to subtract 4y away from each side. So I'd have 3x is equal to negative 4y. Now, think about this in terms of what we could do. I know if I multiply 3 times 4, I would get something that is going to have a result that's an integer. How do I know that? Well, let me show you. Let's put a 4 here for x and we'll continue. Plug in a 4 there. 3 times 4 is 12. 12 equals negative 4y. I know that this divided by this is going to give me an integer because 12 is divisible by 4. So when we think about negative 4, it's divisible by that as well. So we divide both by negative 4. 12 divided by negative 4 is negative 3. That's easy enough. Now, what I could do is I could switch that around. If I'm looking for an easy point, I could say, what if y was 3? Well, if y was 3, I would get negative 12 over here. And I know negative 12 divided by 3 would give me an integer as well. So just look for little tricks like that where you can get yourself an integer to where you're not fighting with a decimal or a fraction. So this equals 3x. Divide both sides by 3. You get x is equal to negative 4. So this is negative 4. And so we have 3 ordered pairs. They're all integers, so it's going to be easy for us to graph. So we have 0, 0. We have 4, negative 3. And we have negative 4, positive 3. So again, come down to my coordinate plane. This is x. This is y. I'll paste my ordered pairs. So the first one is 0, 0. So that's at the origin. That's right here. Now remember, we said that this was a line that passed through the origin, so we expect that point. The next point is 4, -3. So 4 units to the right, that's my x location. 3 units down, that's my y location. 4 right, 3 down is right here. Then the other one is -4, 3. So 4 units to the left, 3 units up. So 4 left, 3 up is right here. And now we just draw a line to connect the points. Okay, make sure you put an arrow at each end. And again, I'm going to label this as the equation 3x plus 4y equals 0. So again, you see something in this format, ax plus by equals 0, you know it passes through the origin. And again, you can look at that and remember that your x-intercept and your y-intercept occur at that point. It's passing through both of those. Okay, it's passing through the x-axis and the y-axis when it hits that origin. So that's your x and your y-intercept. All right, so pretty easy overall to graph a linear equation in 2 variables. I know that the majority of you remember this from Algebra 1, and so this is really just a review for you. But I want to cover something else before we kind of get into slope and start talking about some things in Algebra 2 that we didn't talk about in Algebra 1. Graphing vertical and horizontal lines. This is something that students, even though they took Algebra 1, they still struggle with it. You will see equations such as y equals k. Remember, I told you the definition of a linear equation in 2 variables was ax plus by equals c, where a, b, and c were real numbers, so 0 is a real number, and I said that a and b cannot both be 0, but one of them could be 0. So what I have here is basically the case where this is 0, so 0 times x plus something times y, let's say it's 3y, equals, let's say 6. So 0 times x is just 0. So this is gone. I have 3y equals 6. Divide both sides by 3, and I get y equals 2. So this is an equation where y always equals 2, no matter what the value is for x. So to graph something like that, again, this is your x-axis, this is your y-axis. If y is equal to 2, again, I showed you could write this as 0x plus, in this case, we've already simplified it, so let's just say plus y equals 2. Anything I plug in for x, if I was to make a table of values, will become 0. So let's say I just say, all right, here's x, here's y. Let's say I choose 3 for x. Well, 3 times 0 is 0, so this is going to cancel every time and be 0. I'm just left with y equals 2. So no matter what I plug in for x, it becomes 0, and I'm left with y equals 2. So x equals, let's say, -5. Y is 2. X equals 7. Y is 2. X equals 1,000,000. Y is 2. So y just always equals 2. So what you do for something like this, you just find 2 on the y-axis, and you draw a horizontal line. That's it. That's all you have to do. Okay. And you still want arrows because this goes infinitely in the left and the right direction. Okay, it continues forever and ever and ever. So if I gave you something like, let's say y equals 5. Now let me label this one before we move on. This is y equals 2. If I gave you y equals 5, you would just find 5 on the y-axis. Again, for any x value you choose, y is 5. So if x was -3, y would be 5. If x was 6, y would be 5. If x was 9, y would be 5. So you have an infinite number of points you can make like this. We would just draw a horizontal line, put our arrows, and say this is y equals 5. And let's say I saw something like y equals, I don't know, -7. Well, I just find -7 on the y-axis, right there. Draw a horizontal line. Okay, it's just that simple. Let me label this as y equals -7. All right, so additionally, kind of the last thing we're going to talk about in this lesson, we will see vertical lines. So this is where x equals some value. So again, I go back to my ax plus by equals c. Well, in this case, b is 0, right? So ax plus 0y equals c. For simplicity, let's just say a is 1. So we have x plus 0, y equals c. 0 times anything is just 0. So this simplifies to x equals c, or in this case, we just put k. It just means we're representing k and c. It's just some real number, okay? Can be anything. X could be, let's say, 4. Or x could be 6. Or x could be 10. Whatever it is, it's just going to be a vertical line. So let me show you that real quick. So let's say we had x is equal to 4. Again, I go back to my table of values. If I write this as x plus 0y equals 4, no matter what I plug in for y, x will equal 4. Let's say I plug in negative 3. So negative 3. Well, negative 3 times 0 is 0, so this cancels and becomes 0. You just have x equals 4. And that's true for anything. It doesn't matter what you plug in. So you can pick some points. Let's say negative 3, 0, and 2. And in every case, it's going to be 4 for x. So the simple way to do this is not to plot points. It's just to find 4 in the x-axis, which is right here, and to draw a vertical line. Because no matter what the value is for y, so all these values for y, so at 10, x equals 4. At 8, x equals 4. At 5, x equals 4. At 3, x equals 4. So on and so forth. So it just becomes a vertical line. Okay, and you want to make arrows at the top and the bottom, just to show that that continues forever and ever and ever in both directions. All right, so let's try another one. Let's say x was equal to, I don't know, negative 8, for example. What would I do there? Well, I'd find negative 8 on the x-axis, which is right here, and I would simply draw a vertical line. Again, make sure to use my arrows. Let me label everything, make it clear. So again, this was x equals 4, and this is x equals negative 8. And again, you can look at things and say, well, x equals negative 8. So if I have x equals negative 8, I could really think about it as x plus 0, y equals negative 8. Well, think about some values for y. If y is 4, oh, x is negative 8, so that's right here. If y is 1, oh, x is negative 8, so that's right there. If y is negative 5, oh, x is negative 8, that's right there. So it becomes this vertical line, okay? So if you have x equals some number, find that number on the x-axis, draw a vertical line.